Hello everyone, welcome to today's class. This is teacher Simon taking you through IGCSE Core Mathematics, paper 0580/12 for May-June 2025, and this is part 2 for questions 16 to 25. Question 16, the diagram shows a point P and three triangles A, B, and C on a 1 centimeter squared grid. 1 centimeter squared grid, it means that you have 1 centimeter here times 1 centimeter here to give you 1 centimeter squared. So that is the area of 1 square. Okay, so you take the lengths there as they are in centimeters. Okay, part A, find the area of triangle B. So area of a triangle, you know that it is a half. Okay, it is a half, then base times the height, not so? So a half times what is the base? They told us triangle B. So the base is 2 units. So I'll have 2, then times the height. The height is 1, 2, 3, 4, 5, 6. So 6 units. So times 6 here. Then these 2 will cancel with that, and then we remain with the 6. So that will be 6 centimeters squared. You see that? Or you can even count these boxes 1, 2, 3 that are full. Okay, 3. Now this one, this part that is left here, there's also this other part that is left here. Okay, actually this part here is the same as this part here. So if I get it and I add it onto this one, I'll have now a full box. Do you see that? Then we also have, which other one here? We need something like this enclosed inside to add onto this. It is here, this part here. If I bring it and I add it onto, this one here, I'll make another full square. So unto those 5, then this one here is a half of this whole one. Okay, so that half there plus this half here, they make a whole. So these 2 put together, they give us the 6th one. You see that? So that's why the area is actually 6. You see that? So that is that. The next, write down the coordinates of point P. Look at the x coordinate first, that is a 4. Then the y coordinate is a -3. So we have 4 and then -3. Then Roman 2 here, they are saying work out the coordinates of P after the translation vector -20, then 12. That means here we are moving 20 units. So we move 20 units to the left, and 12 units up. Okay, and 12 units up, because here we have x and y. X is positive when you go to the right, then it is negative when you go to the left. Okay, y is positive when you go up, y is negative when you go down. You see that? Because this one is positive, that means we are moving up, and because this one is negative, then we are moving to the left. So you move like this, then like that. You get it? So maybe if I can put for you a small formula here. If you have the object, then plus the translation, let me actually write it in words. Object, then plus translation, the translation vector, then we get the image. So this P here, we have 4. We shall now add the -20, because this one is done on the x, is the change in the x, this is the change in the y. Okay, then we have the y coordinate of P, which is -3, but we are going to move 12 units up, so plus 12. Okay, so this one will give us -16, -16, and then here 12 minus 3, you will get a 9. So those will be the coordinates of the new image. Okay, part C, draw the image of triangle A after a reflection in this line y is equal to -1. So the object and image must be equidistant from the mirror line. The object and image must be equidistant from the mirror line. So like that. Now when I come here, I'll look for y is equal to -1. This is the one here. I will get my ruler and then draw that line. But to make sure that you don't interfere with what was put there, you make this line dotted. Okay, the drawings that you put here, you make them dotted. This is y, which is equal to -1. Sometimes we even put these markings here to signify the mirror line. Okay, now we are doing what? We are reflecting A. Now A in here, this is 1 unit, then we move 1 unit this way. So when you stand before the mirror, you see yourself the other side of the mirror, right? So if this is the point, then the image has to be here. So we shall have here, because this is 1 unit, then 1 unit. And then this one is 1, 2, 3, 4. Then you move 1, 2, 3, 4. Okay, so that means we shall have the point here. In other words, if this is 3, even this one has to be 3, as simple as that. Okay, now you get your ruler. Please don't connect these ones using your free hands. These are straight edges. You'll be crossed for nothing. Okay, so get your ruler and then you connect them like that. You can even shade this one here if you want. It is optional to shade. Okay, but when you shade, it looks much more much more attractive. So this one is which part we have done. They have not told us to label, but it is part C. So I will just come here and then I put part what? Part C. When you put this one part C, and then when the examiner is marking, can easily see that this one belongs to part C, and then you don't give the examiner hard time, right? The next part D, describe fully the single transformation that maps Roman 1 triangle A onto triangle B. I've already said you always look at the number of marks which are given here. Here we are seeing a 3. That means you think about enlargement, okay, or rotation. Okay, enlargement or rotation. If it is enlargement, because these are 3 marks, how do they come? You tell us it is enlargement, that is 1 mark. Number 2, tell us the scale factor of enlargement. Number 3, you tell us the center of enlargement. If it is rotation, tell us it is rotation. Then tell us the angle and the direction, maybe 90 degrees clockwise, because it can be 90 degrees and clockwise. So tell us the angle and the direction, and then you tell us the center of rotation. Then if we are having 2 marks, then for 2 marks, you think about reflection. So you tell us reflection in the mirror line, you give us the equation of the mirror line. Then it can be translation. Then you tell us translation by scale factor. Translation by which vector. You give us the vector. So those are the 2 marks there. You see that? So that's exactly what we are supposed to do. Now, since here we are having 3 marks, that means we think about rotation and enlargement. So here we have 3, and also here we have 3. So one is probably rotation, and the other one is what? Enlargement. So let us look at A and then B. So we are transforming A onto B. That means A is the object, and then triangle B is the image. So we go to A and B. When you look at these 2, you can see that triangle B is bigger than A. Now, for the rest of the other transformations, we have reflection, we have translation, and we also have rotation. The object and the image, they are congruent, they are the same size. Okay, just like I've reflected this one in here, this one is the same size as this. Okay, you can easily see that A was rotated to give you the C. Not so? They are the same size. But for enlargement, one of them, either the object or the image, is bigger than the other. You see that? So since this one is bigger than this one, that is of course enlargement. So I will come here and I say this is enlargement, then by, give us the scale factor, by scale factor, dash, then by scale factor dash, and what else? We need to find the center of enlargement. Center, we need to find those coordinates. Okay, and how do we find the coordinates? You draw lines through object and image points, through object and image points. Okay, then where these lines meet, where they meet is the center of enlargement. You see that? But then we need to find the scale factor of enlargement. How do you find it? You can do this scale factor. You use this one of these formulas. So we have scale factor of enlargement. You get the image side length. Okay, then you divide by the object side length. So what did they multiply a side with to give you the side of the image? Or you can say image distance from the center of enlargement, then divide by the object distance from the center of enlargement. So let's go and draw these lines here. So I'll get this point here, then I connect it to this one here. Okay, but you just draw all through. Okay, just draw all through. Then after that, you also get, of course, now these two, they are all on the same line. So this one here corresponds to this one. Okay, so I'll draw a line through, and also after that I'll get this one, it corresponds to this one, I draw a line through. Now this one here, I'll just do this line here, the x-axis. This is on the x-axis, just like that. Now again, remember to make these lines dotted so that you don't interfere with what was given. Okay, and then you will see that these two lines are actually meeting at this point, -1. Is it -1, 0? Here, -1, 0. So that is the center of enlargement. So the center is -1, 0. Are we there? Then after that, the scale factor. So the scale factor, we are using image side length over object side length. So image side length, this is the image, B is the image. So I can take this side length here, it is 2 units. Are we there? Then we can divide by the corresponding object side is this one here, which is 1 unit. So 2 over 1 is a 2. I can use this one here. which is 1, 2, 3, 4, 5, 6. Okay, I have 6. Then I divide by 1, 2, 3. What is 6 divided by 3? You get a 2. So that means all these lengths are going to be multiplied by the same scale factor. This one times 2, you get this one. This one times 2, you get this one. The same thing here. This one times 2, you get this other one here. So they are all multiplied by the same scale factor of enlargement. So the scale factor here is 2. By the way, this scale factor can be positive or negative. It is positive if the object and the image are on the same side, okay, of the center of enlargement. What do I mean? When you come here, the center of enlargement is here. So the object is here, the image is here. They are all on the same side. So it is positive. But suppose we had the object here and this image here is this other side. It actually appears inverted, okay? Is this other side. Then the scale factor of enlargement is going to be a negative. You see that? And also another thing you need to know is that if the scale factor of enlargement is a whole number, then that means that the image is bigger than the object. If the scale factor of enlargement is a proper fraction, let's say it's a half, that means the image is going to be below, it is going to be smaller than the object, and you will find maybe the image is around here, smaller, and it has to be before this object in that case. You see that? So that is what we are having there. Then the other one, I said that how you can find a scale factor of enlargement. We have image distance from the center of enlargement over object distance from the center of enlargement. You can come here and you say, if this is the point, okay, I'm referring to this point here, and this is the image point. So image distance from the center of enlargement, our center is here. So if our center is here, this one is going to be 1, 2, 3, 4. Those are 4 units. Then divide by the object distance from the center of enlargement is 1, 2. So you are dividing by 2. So 4 divided by 2, what do you get? Don't you get 2? As simple as that. Then Roman 2, we have triangle A onto triangle C. A onto C, we have already seen this is what? Rotation. So I will write here rotation through, you have to give the angle through what? 90 degrees or what? Clockwise, anti-clockwise. Then you have to get the center of rotation. Now when you look at this one here, it was rotated, I think, like this, because you can see this part that is here, it was horizontal, but then when you look at it here, it is vertical. Now when I bring the two, what is the angle in between them? It is 90. You see that? That is how easily you can see the angle. Look at a side. Okay, this is the one here. It was standing vertically, but then here it is horizontal. So when you put it on this one here, the angle is what? 90. So this is 90 degrees. I will come here through 90 degrees. But we have to talk about the direction. Is it clockwise or anti-clockwise? This one was done like this, not so. And this is clockwise movement. How does the clock move anyway? That is how it moves, right? So that's why we say clockwise. But then if it were moving like this, that is counterclockwise or anti-clockwise. You see? So that is 90 degrees clockwise, not so? All right. So we come here and then we add on clockwise. 90 degrees clockwise. Then the center, you can easily see the center here. In extended, they can't give them something like this. Okay, for them, they make this one distinct. Maybe they bring it around here. So you have to construct perpendicular bisectors, okay, of 2 lines joining a point to its image. Then where the 2 perpendicular bisectors meet is the center of enlargement. But here you can easily see that the center of enlargement is here. They just shifted this one like this, and so in core, in most cases, they give you the center of enlargement as 0, 0, or a point that is on that given what? Object. And that is where you see the object and the image meeting. They are sharing a point. So that point here is 2 and then 3. So therefore the center of enlargement is 2, 3. You see that? Those are the 3 marks. One mark is here, rotation, 90 degrees, clockwise, then the center. Okay? Now, if you don't say 90 degrees clockwise, you can say 270 degrees anti or counter clockwise. Okay? So, if we moved 90 degrees clockwise, okay, then we can also move okay, if we moved what? 90 degrees clockwise, then we can also move counterclockwise. Now we move 270, because when you get 270 plus the 90, you get the 360. Angles at a point add up to what? 360 degrees. So if you move 90 here, then what is left here should give you the 270. You see that? Okay, so that is what we are supposed to have there. Question 17. By writing each number in the calculation, correct one significant figure. Find an estimate of the value of this one here. Okay, so we have 17 here, 0.8. These are 3 significant figures. So if we round to one significant figure, we shall round this 7 here to 1. So we shall add a 1 here. And this one will be a 2. Of course, you cannot move from 17 to a 2. So I'll put what? A 0 here in the place of 7. So it becomes 20. And then 10.3. These are 3 significant figures. 0 is not a significant figure unless it is in between other figures. So here it is counted as a significant figure because it is in between 1 and 3. But suppose I had something like 130. These will be 2 significant figures. 0 here is not in between any other figure. You see that? So one significant figure, I'll round off this 0 to the 1 here, so plus 0. And then this one will be 1. But you cannot move from 10 to 1. So that means I'll write a 0 here. You see that? Yes, it is one significant figure, but I'm having the 10 here, right? The next, we have the 5.5. Now, 5.5, these are 2 significant figures. So I'll round this one to this. So add a 1, then this one will go to 6. That means here we are going to have 17.8 is now what? 20. Okay, then 10.3 is 10. Then we are dividing by 6. This one is going to be 30 divided by 6, and this one will give us a 5. As simple as that. Then question 18, find the highest common factor of 66 and 110. So I can have 66 here. I'm going to use the table. We get 2 numbers that can divide. We get numbers that can divide these 2 numbers, okay, all at once. So we can can we divide these ones by 2? Yes. So if so, we begin by 2, you get a 33. Then by 2, this is a 10 that goes beyond 100. So 100 divided by 2, you get 50, not so? And then 10 divided by 2, you get a 5. So this would be 55. Now, of course, the only number that can divide these 2 is 11. So 11, here you will get what? 3, and here you get a 5. There is no number that is going to divide these 2 apart from 1. You see that? So we shall end there, and then have our highest common factor is going to be the product of these 2 numbers that have divided these, and this one gives us 22. As simple as that. Then question 19, you're saying part AP is a prime number. write down the value of p that satisfies this inequality. So what's a prime number? A prime number is that number that can only be divided by itself. A prime number can only be divided by itself. Of course, when you get a number and you divide it by itself, you get a what? You get 1. So that means it has 2 factors. It has 2 factors. Those 2 factors are 1 and itself. You see that? So which numbers are in here? We have gotten 14, we have 15, we have 16, we have 17, we have 18, okay, within this set here, because 13 is not inclusive and also 19 based on these inequality signs. But if we had less than or equal, then we would have added the 13 and then the 19 here. You get it? So therefore, from here, of course, we can see 14 can be divided by 2, 15 can be divided by 3, 16 can be divided by 2, 17 can only be divided by itself, and then 18 can be divided by 2. So P has to be a 17. Okay. Then next, part B, write down the inequality represented on the number line. So -2 here is included. Okay. So if -2 is included, I'll write it there. Then I'll put less than or equal. Then we shall have x here. And then less than. This 7 here is not included. Like, it is not shaded when you look at this. So that means I will leave this one open. I'm not going to put or equal. You see that? Actually, here there are 2 inequalities. Number 1, we have this one here. Then you look at this one going this other side. Then we have this one going this other side. You see that? So there are 2 inequalities. For this one that goes this way, we are having x then greater or equal to -2. So this one means that you're having -2 then less than or equal to what? X. If I'm older than you, then you are shorter than me. Not so? Okay, that's what it means. Now, when we come to this other one here, this is x is less than 7. So if I have x less than 7, then I will merge these 2 together. Then it will give me this one here. You see that? -2 less than or equal to x less than what? 7. Question 20, we are given this set here, and they are saying use set notation to describe the region shaded. That is J union K. Okay, so union, we put this U here because everything inside the 2 sets has been shaded. So that is that. Then question 21, you're saying work out 2 whole number 7/9 times 1 whole number 1/5, and they're saying give your answer as a mixed number in its simplest form. So using rules of fractions, we are going to have this one here. These are mixed numbers. We need to first convert them to mixed numbers. Okay, so 9 times 2, that is 18. 18 plus 5, that will be 25. So this is 25 out of 9. Then times 5 times 1, that will be a 5. Then plus 1, that will be a 6. Then out of what? Out of 5. Now 5 can go here once, and then here 5 times. Are we there? Then next 3 can go into this one 2 times. 3 can go into this one 3 times. So that means we shall have 5 times 2 in the numerator, and then in the denominator we have 3 times 1. So we shall get 10 out of 3. And 3, the multiples of 3 are, we have 3, we have 6, we have 9, we have 12, and then the rest. But 10 is in between here. But 10 here, we have gotten how many multiples of 3 before the 10? There are 3 of them. So we shall write 3, that is the whole number, and then the remainder is 10 minus 9, that is 1. So we shall write 1 then out of 3. That is what we are supposed to have. And then next, 22. The mass m kilograms of a stone is 3.2 kilograms. Correct the nearest 100 grams. So what do we have here? Now here we are given kilograms, but here they are giving you what? Grams. So let us first convert them to one thing. So 100 grams is equivalent to, first of all, you know that 1,000, also 1,000 grams are equivalent to 1 kilogram. So that means 100 grams would be equal to 100, then times 1, then out of 1,000. These two zeros will go with these, and then you have 1 over 10, which is 0.1. So 0.1 kilograms. So it is rounded to the nearest 0.1 kilogram. Okay, that is the decimal place. You are seeing one decimal place. Okay, now that means I'm going to have, if I can show you something here, if this is 3.2, then here we have 3.3, and then here we are having 3.1. But this 3.2 begins from here, which is 3.15, and then ends in the middle here. You have 3.25. So when you round this one to one decimal place, you are going to get 3.3. Okay, that's why this one ends here. So that means the values that are going to give me the 3.2 will be within this region, below this one, but here we are beginning from here, because when you round this one to one decimal place, you are going to get the 3.2. You see that? So by doing so, this happens to be the lower bound. The lower bound of 3.2, and then this one happens to be the upper bound. Okay, this is the upper bound of 3.2. Now that means this way we went 0.05, and also this way we went 0.05. When you add these two, that is how you get the 0.1. You see that? So I usually write this one here, and I say error bound. Error bound is equal to this one we have gotten, you divide it by 2. Okay, so we shall get the 0.1 divided by 2, you get the 0.05. Then we say the lower bound is equal to that 3.2, you subtract this error bound, and then the upper bound, you get that value 3.2, then you add the error bound. You see that? So that is how we get our answer here, as this one here, when you subtract it, will give you the 3.15. So you write 3.15, and then here we shall have 3.25. So here you are seeing they are putting less than or equal, because we are beginning from this value. When you round it off to one decimal place, you get the 3.2. But when you get this one here and you round it off to one decimal point, you are going to get 3.3. It is no longer 3.2. So that's why this one is not included, and they put just less than. You see that? So it would have been, we consider the values before that one. Those are the ones we take that will give us what? The 3.2 when we round to one decimal place. 23 part A, factorize 9x then minus 6xy. Now this one here is the same as 3 times 3 times x. Okay, then minus 6 is the same as 2 times 3 times x, then times y. Now we pick out what is common. So there is a 3 in there, so I pull it out. There is also an x here. There is an x here. Then what do we have inside here? What are we left with here? It is just a 3. So that is a 3. Then here there is minus 2. There is also y here. So this becomes our answer, factorized. As simple as that. So I just shift that and put it there. Then next, expand and simplify. So this one better, I'm going to say whatever is in this first bracket must multiply with whatever is in the second bracket. So if you have 2x plus 3, then into x minus 4, then this 2x here must multiply with x minus 4, then also 3 has to multiply with x minus what? 4. So then what are we going to get here? 2x times x, you get 2x squared. Then 2x times negative 4, you get negative what? 8. So negative 8x, 3 times x, of course you get 3x. And then 3 times negative 4, you get negative 12. And then this one simplified, it will be 2x squared. And then minus 8 plus 3, that one will be minus 5. Okay? Then minus 12 here. So that is that. And then question 24, we are solving the simultaneous equations below. Okay, now I'm going to eliminate one of the unknowns there, then I remain with one. There are many methods. We can use graphical method, but of course here we don't expect you to use the graphical method because these are straight lines. So you draw the two where they meet is the solution. Usually in this paper here in IGCSE, the space that is left here, you are supposed to use calculus. So you can use substitution method. You make one of the unknowns the subject, and then that is in one equation, then you substitute in the other. You can use elimination method, which I'm going to use here. You can use matrix method. Okay, so using elimination method, I'm going to eliminate whatever you want. You can eliminate x, you can eliminate y. Okay, so let me eliminate maybe y. Eliminating y. To eliminate any of them, you have to make sure that the coefficients are the same. Okay, so here the coefficient is 2, here the coefficient is 4. So I can transform them. I get one equation and then I multiply it with something such that the coefficient is the same. Okay, all right. So I can say maybe in most cases what people do, the coefficient that is here, they put it here, and then this one that is here, they put it here, then they multiply through. But I can easily see here that 2 goes into a 4, right? So if I say multiply this equation 1 by 2, and then this one you leave it, so I'll get 10x, then plus 4y, which is equal to 6. And then this is this other one here, I just leave it because I just multiplied by 1. Then you can see that the coefficients of y, they are the same in the two equations. Then we can just subtract, because if the sign is the same, you subtract. If the signs are different, then you are going to add. Okay, suppose this one was a minus. To eliminate this one, you just add, because now if you put minus, you will say 4 minus minus 4. Do you see that? It is going to give you an 8. So we are going to have a subtraction here because the signs are the same. So 10 minus 3, what do you get? We get 7 of x. Of course, this one has gone. And then 6 minus 27, we shall get negative 21. So this means that x is going to be negative 21 out of what? 7, which is going to give us negative what? 3. Then after that, we can substitute in any of these two equations. We can have 5. 5x is negative 3, then plus 2y, then is equal to 3. So this will be 2y, which is equal to 3. This one will be negative 15. When it crosses, it becomes a plus, right? So plus 15. That means our y is going to be 18 here. Then we divide by this 2 here, which is going to give us a 9. So meaning our answer here is going to be x is equal to negative 3, and then y is equal to 9. Then question 25. The diagram shows a shape made from two different semicircles with the same center. This one here. Okay. And they're saying the radius of the large semicircle is 7 centimeters. So if this is 7 centimeters. That means even this one here is 7 centimeters. Okay, even this way we have 7 what? Centimeters. Okay, then they said that the radius of the small semicircle is 4 centimeters. So this is 4 centimeters. That means from here up to here is 4 centimeters. Even here it is 4 centimeters. You see that? So if from here up to here is 7, that means here we are having 3 centimeters. Not so. Here, because 4 plus 3, you are getting what? A 7. Simple as that. Even here we are having 3 centimeters. You see that? So what else do we have? They said work out the perimeter of the shape, give your answer in terms of pi. So perimeter here is going to be the sum of all lengths around the shape. Okay, perimeter is equal to, we can see the length of this arc here. Okay, I can say small arc length, then plus, there is a 3 here, then plus this one here, the big arc length, and then plus again this 3 here. We are getting lengths around the shape. So this one here, then you come like this, then up to here. Okay, now arc length is equal to theta out of 360 degrees, then times 2 pi r. This is the circumference of a circle, because an arc is part of the circumference of a circle, and the circumference of a circle is given by what? By 2 pi r. So if I have a sector that is like this, this is a sector, that is a sector, okay? But then it subtends an angle here. This is radius and then radius. So if I want to find the length of this arc, so this will be the theta out of angles at a point. So the total angle sum in a circle is 360. But then this arc is part of the circumference of the what? Of the circle. So that's why we are multiplying by 2 pi r. You see that? But then here, this is half of a circle. So if I'm to take the angle, then it is going to be 180. You see that? Out of 360, which is the same as saying a half. Not so. A half. So instead of writing all of that, I will say a half of the circumference of this circle. So the circumference is 2 pi, then r is 4 for this one here, then plus this 3, then plus for the big circle, that arc length is going to be a half, then times again 2 pi r. So 2 pi, but the radius of this one is what? 7. So times 7, then plus the 3. You see that? So what are we going to have? Of course, this one will go with this one will go with this one here. You have 4 pi here, then plus 3 plus 3, that one gives us about 6, then plus this will be 7 pi. So 7 pi. Then what do we have here? 4 pi plus 7 pi, we shall get 11, not so. That will be 11, then pi, then plus the 6 here. So they said we write our answer in terms of pi, so pi must remain there. Don't say 11 then times the 3.14, because you know that pi, its value is that one, its estimate is 3.14. Just leave your pi in the answer. Okay, so this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.